right, this is going to page 24 when we're done. You will notice sometimes in these lessons things might seem a little repetitive, like we kind of said some of the same things in the last lesson or the lesson before, and that's all fine and great because sometimes we need to hear things more than once, but we're also just kind of tying it all together. So in the previous lesson, we looked at rates of change, multiple representations, and whatnot. So in this lesson, we want to consider rates of change in linear and quadratic functions, which again is not a completely new concept for you, but the wording that we're using and how we're applying it, that is probably going to change a little bit, okay? So we talked about secant lines and tangent lines the other day, whenever it was. So we're going to look at, so the average rate of change is going to be the slope of our secant line. This is our secant line right here because it intersects the function at 2 points, right? So the slope of the secant line and the average rate of change go hand in hand. Okay? That's basically what it is that we are finding. And it's always over an interval, a closed interval, because we have to use the endpoints, right? And you've been doing this since your first algebra class. Like, it's just old school slope. Average rate of change, I think I've kind of already mentioned this. It can be abbreviated as AROC. I left that in here on some of these, so make sure I talked about this. We are not going to write it as AROC because there's a slight chance that we might not get credit for that if we abbreviate it, and we don't want to risk any of that stuff. So we can abbreviate like some words in it, but we're not going to abbreviate it as AROC. I think we should be able to, but again, we don't know. But either way, average rate of change is the slope of the secant line. So the M we know is slope, and then that little subscript, SEC, means secant. So this represents the slope of the secant line. And that's just using notation instead of writing out. Change in y over change in x. We got our function notation for our slope. Okay, everybody good with that? All right, so we have the graph of y equals f of x over here. We're going to sketch the secant line through the points. Now, your ID makes a phenomenal straight edge, so you can plop your ID right up on the table. So yours can actually be straight, where mine is going to be sort of straight. Well, even if it's straight, I'm still missing my point. Okay, whatever, that's close enough. We can pretend. Oh, I kind of skipped a thing up here. The actual, like the secant line is the line joining 2 points in a function. That's the way we're looking at it. Doesn't have to be that exactly 2 points. So here we've got 2 points. It goes through a third point. We don't care about that one. Okay, we're just looking at those outside too. Now we want to find the slope of the secant line from the 2 points that they gave us. So we are going to use our notation, slope of the secant line equals, and then we're going to put things in function notation, all right? So it's always the change in y over the change in x. My x's are 3 and negative 2, so this is 3 minus a negative 2. I think it's kind of safer maybe to put those in first. Then I want, that's going to be f of 3 minus f of negative 2. There it is in function notation. Figuring out our y values for this, not that hard because they gave us ordered pairs, right? What is f of 3? 4. What is f of negative 2? Negative 6, right? And then what is 3 minus a negative 2? 5. What is 4 minus a negative 6? 10. So I have one person in here that knows their positive and negative integers. Good job. And we get 2. Thank you for participating. Okay, so the slope of the secant line is also known as the average, so we can abbreviate average as AVG, average rate of change of F over, and then it's always going to be over a closed interval. Your interval is always going to be your x's. So we're going from negative to to 3. The slope of the secant line is the average rate of change of the function over an interval. What questions do you have? Everybody good? Not a whole lot of brand new stuff here, right? We're just, okay. All right. So for this function, g of x, find the slope of the secant line from this point to this point. So we're going to write out slope of the secant line. All right, so go ahead and write out your fraction here. What would it look like in function notation? Something like that. Would you agree with that? Okay. So then we have to find g of 2 and g of negative 1. In order for me to find g of 2, do I have to multiply these two things together first before I substitute anything in? No. I could, but why would you make your life harder, right? So we're going to find g of 2. That's going to give me 2 plus 4 times 2 minus 2. And what will that give me? 0, exactly, because 2 minus 2 is 0, so the fact that this is 6 is kind of irrelevant anyway. And then you find g of negative 1. We get negative 9? Yes? All right, so then we're going to substitute that back in up here. G of negative 2, which is 0, minus g of negative 1, which is negative 9. 2 minus a negative 1 is what? 3, so that gives me 9 over 3. So the slope of my secant line is 3. Okay. What questions do you have? Notice a couple of things. I don't just have random work all over the place. I have this very clearly labeled that g of 2, this is where I got it from, this is what it is. G of negative 1, this is where I got it from, this is what it is. You need that for yourself and for the person you're. Okay? What questions we got? We all good? All right, flip it over then. So we're going to look at average rate of change for linear functions and then also quadratic. Okay? Now you've been doing slope of linear functions, again, like I said, forever. Got to make sure we got some vocabulary down here. So the average rate of change over any length input value interval is constant. So for a linear function, it's constant. That's why the slope of the line is 3. It's always 3. That is your slope, right? That's, again, kind of old business. But what we're also going to look at is how does the rate of change change? And here's where you can get lost in all those words again. Okay, we understand rate of change. I think you get that your rate of change can change, right? When we start talking about the rate of change is where you start to give me these blank looks again. Okay, so we just kind of have to make sure we don't get lost in the words and we understand exactly what that means and where that's coming from. Okay. So since the average rate of change is constant, the rate of change is always 3. The rate of change does not change, right? Because it's constant. So the rate of change is 0 because it does not change for a linear function. The rate of change is going to be 0 for a linear function because it does not change. Changes at a rate of 0. All right. Now let's look at this table and we'll label some things on here. So we got this. We're going to find the average rate of change over the given intervals. Now I'm going to, we're going to leave out the function notation part of this because there's not a whole lot of room to write in here anyway, and it'll take us forever, so it's fine. If you're not going to do the the function notation of it, here's what I suggest you do. I'm going to find my slope on this interval. I'm going to write my x's in here first. -1 minus a -2. Then I'm going to look over here and say, what is h of -1? What is it? -5, so that goes first. Minus, what is h of -2? -7. Okay. So -5 minus a -7 is what? 2. Over 1 minus a -2 is 1. So I get 2. Okay? Make sense? It's just basic slope. Okay? Go ahead and do the next 3. All right, we get 2 for all of them. Yeah. Okay, so then you can see here that your average rate of change is constant. Which tells you that it's linear, and that's one of the things that you did do in Algebra 1. You'd find oh look, that's why I can find any 2 points, and my slope is going to be exactly the same, right? Now, if we want to look at how this is changing, how does the average rate of change change? I'm going to look at the change in these 2 values. So 2 minus 2 is 0. The change in these 2 values, 2 minus 2 is 0. The change in these 2 values, 2 minus 2 is 0. So this is the change in average rate of change. It does not change. The change in the average rate of change is 0 because the rate of change is constant. Okay? And even though that might seem super obvious, you're asked these kind of questions with words, and they're not done to try and confuse you or trip you up, but if you haven't talked about it and thought about it this way, the words can get confusing in your brain. So it says, what is the change in the average rate of change? Here's what we're going to say. The average rate of change of H is constant. Therefore, then it says, what is the change in the average rate of change? The change in the rate of change is 0. What questions do you have? Do you understand how that works? Just lines. We're not trying to make it harder than anything. Just think about what you know about a line, what the slope means, what the rate of change means, the fact that it's always the same. You know, make it all make sense. Okay? All right, so now let's look at average rate of change and quadratic functions. So the average rate of change over consecutive equal length input value intervals. Now you're going to hear that phrasing a lot. Consecutive equal length input value intervals. What that means is this. Your x's are changing, no matter what's happening with your y's, whether they're changing at a constant rate or not, your x's are changing at a constant rate. So here, see here, these just go up by 1 each time, or they could go up by 2 each time, but it can't go up by 1, then by 3, then by 2, then by 1. It can't jump around, okay? So that's what consecutive equal length input value intervals mean. So the average rate of change over that can be given as a linear function. So the average rate of change of a quadratic can be represented by a linear function. That is definitely going to be something you were asked. We've got to make sure we can make that make sense, okay? Then the rate of change of the average rates of change, okay? Rate of change of the rate of change of a quadratic function is constant. Rate of change of linear is 0. Rate of change of the quadratic is constant. Okay? It's changing at a constant rate. All right. Now let's find these average rates of change here. We've got, so I'm going to go from, let's see, -1 minus a -2. Then f of -1 is 3. Minus f of -2, which is 11. What is 3 minus 11? -8. Good. Over 1. So that's -8. All right. You go ahead and find the other 3 slopes. Okay, so there's a couple of things we want to look at with our rates of change. If you were going to be asked, is this function linear, quadratic, or neither, right? It's definitely not linear, right? If it was linear, all these numbers would be the same. You agree with that? Okay. So then we'll talk about how we could find quadratic, but for sure we know it's not linear. The other thing that we're going to look at in just a second is what is happening. So the rates of change are not constant. What is happening? Are these rates of change increasing or decreasing? They're increasing, okay? And then let's see what the change is here. So the change, to find the change in those two, it'd be -4 minus a -8. What does that give you? 4, good. And then the change in these two would be 0 minus a -4, which is 4. And then these two, 4 minus 0, which is 4. Okay? So not only are they changing, but they are changing at a constant rate. Does that make sense to you? This is the rate of change of the rate of change. This is the rate of change of the rate of change. That's what this is here. Okay? The rate of change of the rate of change. So when it asks us, what is the change in the average rate of change? We can say the average rate of change of f is changing at a constant rate of 4. So the average rate of change is changing at a constant rate of 4. Okay. What questions do you have at this point? Anything? Okay. Let me give you your second page here. I think that's 5. If not, I'll come back. I think that's an extra, and you just leave it on the table. They're just hard to separate sometimes as I'm walking around. Alrighty. So this is also going on page 24 when we're done. Okay, does everybody have enough? Did it count right? Okay, 3 essential facts. Over any length input value interval, the average rate of change of linear is constant. Again, that's old news. And the reason this says any length, it doesn't matter if it's consecutive, equal length, is because I can pick any 2 points on a line, find the slope, I should get the same number, right? So again, kind of old news there. Given, again, consecutive equal length input value intervals, the average rate of change of a quadratic can be given by a linear function. We'll look at what that is eventually. And then we also know that the average rate of change over the closed interval is the slope of the secant line. Okay, so 3 basic things we've just talked about that we got to make sure that we can keep right in our heads. Everybody with those so far? Okay. Now this is going to look like a little bit of a repeat, and it kind of is, because I talked about concavity more than was really necessary in 1.1, but I did that because otherwise we really couldn't have talked about the fun chart, and without the fun chart, I think everything would be way more confusing right now than it already is. So we're talking about now a quadratic. We can determine the curvature or concavity of the graph considering the average rate of change over equal length x intervals. And here's the thing. We've been talking about graphs that might look like this, right, or whatever. For a parabola, it's either always concave up or always concave down, right? It's not going to change because just the nature of a parabola. You with me on that? All right. So here we've got concave. It says sketch the slopes at each point. So really we just kind of sketch the tangent lines that we can't really find. And we can look at this a couple of different ways. Look at the lines. You can also kind of use your pencil. So when I put my pen up here, this slope is negative, right? And as x goes from left to right, it's negative, then it's 0, then it's positive. So clearly when it's concave up, the slope is increasing. When I do that over here, I have a positive slope, then it's 0, then it's negative. So clearly the slope is decreasing when it's concave down. But we did already know that, so write your fun chart out. Try without looking up here. We knew that from our fun chart, right? If the function is concave up, the rate of change is increasing. If the function is concave down, the rate of change is decreasing, whether it's the average rate of change or the actual rate of change or whatever. Okay, we good on that? So again, kind of a repeat, kind of old business, but one thing I did want to remind you about right here, I mean, this is in general, but for if you know you have a quadratic, it's either always concave up or always concave down because nothing else would really make sense. Okay, and then this, I think, just kind of repeats that, yeah. Concave up, average rate of change, increasing, concave down, average rate of change, decreasing, but remember it says over equal length input value intervals. That is what's going to be important to us when we are looking at charts for this. Okay? Equal length input value intervals. So we've got the table of output values, input, so we've got x and h of x here. And we're going to find these average rates of change again. And so once I look here, these are changing by 2. And that's fine because it's a consistent 2 as far as the x values are concerned. So I'm going to find my slope here, -2 minus a -4. And then on top, f of -2 is -2 minus f of -4, which is -20. All right, -2 minus a -20 is 18 over -2 minus a -4, 2. And that becomes 9. Okay. All right, then go ahead and find the rest of these. I know some of y'all are still working on those average rates of change, but is this a linear function? No. Is this a quadratic function? I know that's not what the question's asking, but what's 3 minus 9? -6. -3 minus 3? -6. -9 minus a -3? -6. So is this a quadratic function? Yes, because the average rates of change are changing at a constant rate. That's how I would know that it's quadratic. Does that make sense to you? Okay, again, not what this is asking, but you could totally be asked that, so why not practice now? All right, so let's actually answer this question then. It says, what do you notice about the change in the average rates of change? Are your average rates of change increasing or decreasing? Decreasing, okay. So they are decreasing. So then it says, what does this tell you about the concavity of the quadratic function? Is it concave up or concave down? Down. Okay. So this is what we would need to write. Is it H, F? What are we calling this thing? H. Okay. H is concave down. Now, one difference between this and what we did originally is I don't have to put an interval. Because it's a quadratic, it's always concave down, so I don't have to state an interval. So H is concave down because the rates of change of H are decreasing. Okay. What questions do you have? We all good on that? Yep. All right, good deal. Flip this over then. All right, kind of, again, repeat to make sure that we understand this. In general terms, we can say that a function increases over an open interval of its domain if the graph rises from left to right on the interval, right? The function increases if we go from left to right and the y values get bigger. Likewise, a function decreases over an open interval if it falls from left to right on the interval. It's important to note that the intervals, this is why it's bolded, intervals refer to the x values where the y values either increase, decrease, or remain constant. So what we've been doing, and like I have said multiple times, we talk about y, we look at y, we write about x. Okay? So function vocabulary, when the input values increase, and the input values will always be increasing. When the input values increase, we're going from left to right. The output values will increase. That means this is increasing functions, not rate of change. Right? You've got to make sure we know which one we're talking about. And again, input values will always increase. The output values decrease. That is decreasing functions. Right? Then we got concave up and concave down. This is when the rate of change is increasing and when the rate of change is decreasing. Those are two different things. This is when the rate of change is increasing and decreasing. This is when the function is increasing and decreasing. Okay? Does that make sense? What questions you got? All right, we're going to stop here for today because I want to give you your quizzes back and talk about a couple of things.